A very good morning to our beloved lecturers and all my fellow friends. As you can see, today we from Group 8, we would like to represent Case B, which is the conversion of potential energy to kinetic energy. And the first experiment will be the pendulum. And the second experiment will be the marble on the inclined plane. Let's get started.
Assalamualaikum warahmatullahi wabarakatuh. Our group will conduct about to understand the conversion of potential energy to kinetic energy. So for the first experiment, we conduct the experiment using pendulum with the three significant different angle using 45 degree, 90 degree and 110 degree. The objective is to determine the maximum velocity when it moves from the beginning point at the angle. So when it arrives at the equilibrium position, the maximum velocity occurred at there. So we let it do the full cycles of the swing. Okay, untuk eksperimen yang pertama kita akan menggunakan sudut 45 darjah. Okay, sudut 45 darjah. Jadi kita pastikan bola kita berada di jalan yang betul. Lepas tu kita angkatkan dia sebanyak 45 darjah. 45 darjah. Lepas tu kita jatuhkan dia dan biarkan dia melekatkan satu pusingan yang lengkap.
A very good day, Miss Yong. So today from my group, I'm going to do a swinging pendulum project, and my part is 90 degrees. So I'm going to place this swinging using this tennis ball as a swinging pendulum. So I'm going to place this as a 90 degrees angle. So from here I'm going to let it.
Experiment 1, for angle of 110 degree, we will pull the pendulum to 110 degree, then we will release it to make one complete swing.
Untuk calculation untuk sudut 45 darjah, kita menggunakan theorem conversion of potential energy to kinetic energy. Formula dia adalah mgh equal to 1/2 mv square. Apabila m constant tu kita boleh hapuskan, maka kita akan dapati velocity equal to square root 2gh. Jadi yang h ni adalah yang L ni tolak dengan L cos theta akan dapat h. Jadi ikut formula dia, kita gantikan balik h tu dengan L kurungan 1 tolak cos theta. Lepas tu kita masukkan nilai-nilai yang kita dapat daripada result dan yang diberikan, maka kita akan dapat V equal to 1.31 meter per second. Jadi kita conclusion dia V max equal to 1.31 meter per second. Sekian.
My name is Sivanandan. So today from group 8, and I would like to present about the calculation of swinging pendulum. So as you can see, the mass of the tennis ball is 50 gram and the length of the thread is 0.3, and the angle is given for me to calculate is 90 degrees. So here is the simple sketching of a swinging pendulum of a 90 degree angle. So the main calculation is using conversion to potential energy to kinetic energy. So as you can see, the formula is given mgh is equals to 1/2 mv square, and whereby m is equals to constant. So v square it will be gh. So v is equals to square root 2gh. So to calculate the h will be length minus L cos theta. So L cos theta we will be converting to 1 minus cos theta. So as you can see, we have to substitute this. If you want to find the V, you have to substitute this formula into the given units. So it will become 2gl1 minus cos theta, whereby 2g is 9.81, L is the length 0.3, and 1 minus cos 90 degrees, because which is given 90. So once you calculate this, you will be getting 5.886. So this 5.886 we have to square root and we'll be getting 2.426 meter per second. So the total velocity maximum is 2.426 meter per second.
So to get the velocity, we will use theorem conversion potential energy to kinetic energy. So the formula is mgh equal to 1 over 2 mv squared. M is constant, so we can cross both of it and rearrange the equation. We will get v equal to square root 2gh. To get h value, we will use h equal to L sin theta plus L, where L is 0.3 and theta is 20. So h we will get 0.403. Then we will substitute h into v equation and g is 9.81. So we will get v equal to 2.81 meter per second.
Okay, experiment 2, bubble on the inclined plane, is an experiment which allows an object to roll on a smooth surface in order to accurately calculate the velocity and time. So in this experiment, we have set the max distance for the bubble to roll is 3 meters. We will start with the significant 3 different angles, which is 25, 35 and 45. So what are you waiting for? Let's get started. Okay, for the second experiment, I'll be conducting the inclined plane for 45 degrees. I'll be using the house wiring casing as the inclined plane.
So for 45-degree angle, the distance marble travel is 1 meter and time taken is 0.84 seconds.
So for the angle 35 degree, the distance marble travel is 1 meter and the time taken is about 0.63 seconds.
So for 25 angle, the distance marble travel is 1 meter and time taken is 1.68 second.
Okay, for the experiment of inclined plane for 45 degree and the length given is length of the inclined plane is 0.3 meter and the length of the horizontal is 1 meter. So by using the formula equal to mgh equal to half mv square, as we know that g is equal to 9.81 and h we have to calculate by using the theorem Pythagoras, which is the sine 45 equal to h over 0.3, and we will get the h is equal to 0.2121. Then we just substitute into the formula and then we get the velocity is equal to 2.040 meter per second. And then we have to use the formula of v equal to s over t, which is the 1 over 0.84, and then we get another velocity, which is the 1.19 meter per second. If we compare to both of the velocity, it is quite varied to our experiment. Thank you.
My name is Sivanandan Laki Subramaniam. For experiment 2, we will be using 35-degree angle. The length of inclined pendulum is 0.3 meter. Length of horizontal plane is 1 meter. Time taken is 0.63 second. Velocity is 1.837 meter per second. So how we're going to find the calculation is by using mgh is equal to 0.5 mv square, whereby m is equal to constant, h is equal to, we have to use this formula, so we'll be getting 0.1721. We have to substitute this one into this, so g is 9.81 and h is 0.721, 0.5 v square. So v square will be 3.374. Square root of v is equal to 1.837 meter per second, whereby v is equal to s over t and s is equal to 1 divided by 0.63. We'll be getting 1.587 meter per second.
For experiment 2, to get the velocity, we will use the formula mgh equal to 1 over 2 mv squared. M constant, so we can eliminate both of it. Then rearrange the equation, we will get v equal to square root 2gh. To get the h value, use Pythagorean identities. and h we will get 0.128. Then substitute h into v equation, and g is 9.81, so v we will get 1.58 meter per second.